Welcome back, Dragons. We've got one more page for today, AIM page 70. We recently completed equivalent ratios over here. I had equivalent ratios represented in tape diagrams, double number lines, and proportions, and we used a lot of scaling up and scaling down. We're going to complete two more representations today. This is a soda example. I purposely did not work this out in advance so that you could see my reasoning skills as I try to unravel this page. I did not create this page, so I found this page and I'm going to create it along with you. I'm going to fill it in with you. So here we've got ratio tables and graphs, and we've got a word description here. Market Basket is selling 2-liter bottles of soda for $1.30 each. They want the original ratio written here, and I do know that this means price per unit. So that might not be a vocabulary term you are familiar with. So that abbreviation means price per unit. Now, this is a rate. A rate is a ratio that is a comparison of two different items with two different units. This is liters versus money. So it's two different worlds. When it says price per unit, it makes me think that this top one is the price, and this bottom one is the liter. So I'm going to put liter here. Because per means 1. So the original was $1.30 per 2 liters. So we got to scale down. How much is it going to be for just 1 liter? So you can either multiply by a half or divide by 2. Either way, you're scaling down. So it's $1.30 cut in half. So $1 cut in half is 50. 30 cut in half is 15. So that's 65 cents per liter, per 1 liter. So the price per unit, this is basically the unit rate. I don't know if you remember that term. This guy, he's the unit rate. There are many advantages to the unit rate. One being you can go anywhere from 1. Like if you know what 1 is worth, you know what 2 is worth, 3 is worth, etc., etc., etc. So they have a graph and a table. To me, it makes no sense to do the graph first. I would need a table to have all the ordered pairs. And you guys did an excellent, excellent job with ordered pairs. So if you've got no liters, you didn't spend any money. If you've got 1 liter, we know we're going to spend 65 cents. If you've got 2 liters, we know that it's $1.30. So what would 3 and 4 and 5, how are you going to go about this? Well, you've got a couple choices. Since this is in sequential order and you're just adding 1 each time, you could just add 65 cents each time. Or you could scale up and down if you feel like doing the multiplication. Either way, we can easily fill this in. So I need $1.30 plus 65 cents to get to the next one. So that would be $1.95. And then I need $1.95 plus 65 cents to get to the next one. So that would be 0, 15, 16, I think $2.60. I'll check this in a minute. $2.60 plus 65 cents, probably $3.25. Okay, $3.25 plus 65 cents, probably $3.90. Yep, $3.90. Then we're going to do $4.55. And we're going to do $5.20. Yep, $5.20. Then another 65 cents, so $5.85. And then another 65 cents. Should be $6.50 in theory. Let me make sure that's right. Yep, $6.50. Okay, let's double check before we try to make some ordered pairs out of this. So 0.65 plus 0.65 was 130, plus 0.65 equals 195. 0.65, whoops. 130 plus 0.65 was 195, plus 0.65, 260, plus 0.65, 325, plus 0.65, 390, plus 0.65, 455, plus 0.65, 520, 585, 650. Okay, so our table consists of a series of equivalent ratios. And if it's proportional, what should the graph look like? What's our prediction? I'm hoping for a straight line. Otherwise, we've made a huge mistake. What's great about the table is you already have your ordered pairs. For example, this ordered pair is 0, 0. This ordered pair is 0.65. This ordered pair is not 0. You saw that. You saw that arrow. It's error. It's supposed to be a 1. 1, comma. This one should be a 2, comma. Sorry about that. $1.30, and so on and so forth. So they are already in ordered pair format. It's fantastic. Now we need to make some, they don't really have axes. They kind of gave us a y-axis, but they didn't really give us an x-axis. I feel like I want to take a straight edge and make an x-axis. I don't have a ruler, so I'm going to use maybe the side of my stapler here, getting creative. I'm just going to trace one of the lines they already have, and I'm going to make that the x-axis. And I'm going to make this guy, I'm going to trace him to darken him. I'm going to make that the y-axis. So your axes are like rays. They go on. And really, they're like lines because they would go on into the other coordinates. But right now, we're really just in the first coordinate. So this is x. And this is going to be your liters. And this is y. This is going to be your money. X is the independent variable. Y is the dependent variable. You don't spend money unless you have liters. Now, my question here is, how many spaces? They want us to do 10, which require 20 squares. Do we have 20 squares? 2, 4, 6, 8, 10, 12, 14, 16, 18. Not quite, but if we don't skip every other, I think it's going to be a crowded graph. Let's see. 2, 4, 6, 8, 10, 12, 14, 16. Well, looking at that, we're only going to be able to graph up to 8. But I think even just graphing 8 points will give us a really clear understanding of the shape of the graph. So this is the origin at 0, 0. And I'm going by liters. I'm going to go, that's 1 liter, 2 liters, 3 liters, 4, 5, 6, 7, 8. I'm happy with that. We're not going to get to 10. Now, think about what interval you're counting by on this. And I think we should do every other on this as well. It'll make the graph more clear. And these are choices I'm just making right here with you right now. I'm looking at it. I'm looking at my table. I'm trying to make reasonable choices on how to space this out evenly and fairly using the grid provided. I think we should just skip count by 65 cents. We already have it. We don't have to redo the math. We just have to copy it. Not going to get past that, I guess. Otherwise, I'm going to start falling off the grid. So, going in with a different color to create to plot my points. Going in with red. Here we go. So, if I have no leaders, I spent no money. No money, honey. If I have one leader, that was worth 65 cents. If I have 2 liters, that would cost $1.30. 3 liters should be $1.95. 4 liters is $2.60. That's here. 5 liters is $3.25. 6 liters is $3.90. 7 liters is $4.55. That's pretty. Nice graph. Alright, again, I don't have a ruler. Not in this room, at least. I'm going to use now the tape dispenser doesn't work. The stapler works. So I'm going to get creative. I'm going to connect those dots. You're going to see when I move this that it shows a linear proportional relationship. This is fantastic. So you can see that equivalent ratios create a linear relationship on the graph. These are all equivalent ratios. And Honors and I talked about equations that go with this graph. Like y equals mx, or y equals mx plus b. We took it to an algebraic level where we assigned an equation to the graph to show that the relationship is proportional. In this particular one, because it goes through the origin and it's linear, and it has a proportional relationship, it has something called a constant of proportionality. So this particular graph would be y equals kx, where k is how much it increases each time. What do you have to multiply x by to always get the value for y? I would multiply x by 0.65 to get y. 2 times 0.65 gets you $1.30. 3 times 0.65 gets you $1.95. 4 times 0.65 gets you $2.60, so on and so forth. So there you have a linear relationship. What will be the price of 6 liters of soda? We can just read the graph. 6 liters will be $3.90. Don't even have to do any new math. The 3-liter bottles of soda are selling for $2.10. In a different color, graph the price of 3-liter bottles. Ooh, a 3-liter bottle is selling for $2.10. Where is $2.10 on our graph? Let's see. That's $1.95. Let's see. 65 cents divided by 2 would be about 33 cents. So $1.95 plus 33 cents makes this particular line, going with a different color, about $2.28. I'm just trying to make a really educated choice here. And it says this thing's going to cost $2.10. So that's going to be between here and here, but at 3 liters. Oof. So it's going to be slightly above. So this is a 3-liter bottle. Sneaky. Because according to our data, it's $1.95, but according to this data, they're selling for $2.10. They're making actually a little more of a profit. Sneaky McGee's. So this is your 3-liter bottle. If you need to buy 10 liters of soda, would it be more cost effective to buy 2-liter bottles or 3-liter bottles? Why? My instinct says 2-liter bottles. Let's see. if for every 2 liters, it's $1.30, and we want to get to 10 liters, I would have to multiply by 5 by scaling up. I'm going to make sure you can see that. Multiply by 5. So that would be $6.50. In contrast, and this is not going to be a friendly number, we've got $2.10 for 3 liters, and we want 10 liters. This is a yucky number. This would be times 3 1/3. Yeah. Times 3 1/3. So 210 times 3 1/3. I am not in love with, which would be $6 and might end up being cheaper. That seems unusual. I'm feeling like maybe I made an error earlier. No. There we go. So almost $7. Approximately $7. That's tough. I want to see if I can put it into a... This is 2 10/100, so this is 2 1/10. I'm trying to think of a way to do it with precision. 2 1/10 times 3 1/3 is really what I'm multiplying. So I've got 21/10 times 10/3, which is going to get me 210/30. That's still going to get you like $7. So we're just going to call it $7. Okay. So my instinct was right. 2-liter bottles are better. That makes sense because our graph indicates that a 2-liter bottle should be better. It wasn't like it was a surprise. But this wins. So the question asks why. Why is because it costs less. Why would it be better? Why is it more cost effective? If we scale it up, we can see that's more cost effective. You could prove this an alternate way. You could go take this down to the unit rate and you would see that price per liter is 70 cents on this one. And how am I doing that? $2.10 divided by 3 is 70 cents per liter. We know the other one's only 65 cents per liter. So either way, the unit rate is cheaper for 2 liters versus 3 liters. If we scale it up using our other mathematical skills, you still 2 liters wins. Biggest difference I can see, though, is this is not practical. This is more cost effective, and you would have literally 5 bottles. You can't have 3 1/3 bottle. You would have to buy 4 bottles. You would have no choice. So do you want 4 bottles? And then by purchasing 4 bottles, you've spent more money. You'll get more product, but you've spent more money. So that's kind of a lose-lose situation too, depending on what you're trying to accomplish. I would go with 2 liters on this one. I don't have an answer key for this. So if you have any concerns, feel free to message me and see if you would like to debate this further. But I would go with the 2-liter bottles. So there you go. We got AIM page 70 done, and that's the last for today's work. I'll be posting some other pages for you tomorrow. Thank you, Dragons.